Hi, Assalamualaikum. My name is Muhammad Aiman Azim bin Abdul Aziz. My metric number is J20A0497. I will continue with radiographic testing. First, radiographic testing or RT is a non-destructive testing method for examining the internal structure of any component to identify its integrity. Radiographic testing uses X-ray and gamma ray to produce a radiograph of a test specimen that shows change in thickness, defect or flaw, and example details to ensure optimum quality. In radiographic testing, the part of to be tested is placed between the radiation source and a piece of sensitive field of detector. Once the X-ray or gamma ray radiator is started, the test part will hinder some of the duration by its material density and thickness. Thicker and more dense material will allow less radiation to pass through the specimen. The film or an electronic device records the amount of radiation, known as radiograph, that reaches the film through the test specimen. By studying the radiograph data, defect can easily be recognized. If the material is found without any defect, entire ray will evenly pass through the material. But for material containing flaw, ray passing through the flaw will get absorbed to a small extent due to change in density.
Magnetic particle inspection, often known as magnetic testing, is a non-destructive inspection procedure that detects linear faults near the surface of ferromagnetic materials. It is mostly used for surface inspection. The magnetic testing is a highly successful method for locating surface breaking and minor subsurface defects in magnetic materials, such as cracking, porosity, absence of sidewall fusion in welds, and so on. So there are several methods. The most adaptable method is to use a 110 volt AC handheld electromagnetic yoke magnet, a white strippable pen as a contrast background, and a magnetic ink made of iron powder particles in a liquid carrier foundation. The area is magnetized with the yoke magnet. In the event a surface of slightly subsurface defect being present, the lines of magnetic force will deform around the defect.
Ultrasonic testing is one of the more common non-destructive testing methods performed on material. This testing utilizes high-frequency mechanical energy, that is high-frequency sound wave, to conduct examination and measurement on a test area. Typically, the UT or ultrasonic testing inspection system consists of a ultrasonic transducer, pulsar and receiver and display unit. A pulsar and receiver is an electronic device that can produce high voltage electrical pulses to the transducer. When driven by the pulses, the transducer generates high frequency ultrasonic sound energy into the material in the form of sound wave. When there are discontinuities such as inclusion, porosity, crack, and each other in the sound path, part of the mechanical energy will be reflected from the discontinuities surface. The reflect sound wave signal retrieved by the transducer is then transformed back into an electrical signal, and its intensity is shown on this display unit. The sound wave travel time can be directly related to the distance that the signal has traveled. From the signal, information about reflector location, size, orientation, and other features can be determined.